This is the first question in our Hardy-Weinberg extra practice problem set. The question asks if this population is in Hardy-Weinberg equilibrium. To answer this question, we'll have to calculate our observed genotype frequencies and compare them to our predicted genotype frequencies. So let's start. We have a copepod population that exhibits long antenna and short antenna. The long antenna is the dominant trait, so I'll use capital A to indicate that trait. Short antenna is the recessive, so I'll use little a for the allele. In our question, I told you that we observed 20 homozygous dominant individuals and 200 recessive individuals. This is out of a total population size of 300. Out of that 300, I already have 220 individuals accounted for, which means we have 80 heterozygote individuals. Now, from this information, I can calculate our observed. Our observed is 20 individuals over 300 total individuals to get a frequency of 0.06667. I'd do the same for their heterozygote and the same for our recessive individual. These are our observed genotype frequencies. We will use these to compare them to our predicted genotype frequencies. In order to calculate our predicted genotype frequencies, we must first calculate the allele frequencies. So we'll start with our dominant allele. The dominant allele frequency is also P. We take 2 times the number of homozygous dominant individuals plus the number of heterozygote individuals divided by 2 times our population size. Using a calculator, I get 120 divided by 600, or 0.2. I'll also check my calculation by calculating the recessive allele frequency, little a, which is also Q. This is 2 times our recessive individuals plus our heterozygote individuals divided by 2 times our population size. I get 480 divided by 600, which is equal to 0.8. With these allele frequencies, I'll now calculate our predicted frequencies, assuming that our population is in Hardy-Weinberg equilibrium. So P squared is 0.04. That is our predicted homozygous dominant genotype frequency if our population is in Hardy-Weinberg equilibrium. 2pq, this is our genotype frequency of the heterozygote. 2 times 0.2 times 0.8. That's 0.32. And lastly, our q squared, which is 0.64. That 0.64 is our predicted genotype frequency of the homozygous recessive. Now, we have our observed and predicted, and we compare them. As you can see, none of our observed frequencies match our predicted. Because of this, we can conclude that our population is not in Hardy-Weinberg equilibrium. If it's not in Hardy-Weinberg equilibrium, then we know that our population is evolving.